We're going to start looking at polar graphs. So the polar coordinate system, try to find, this is what it looks like here. It kind of looks like a target or a bullseye or something. But the way you graph the points is you have the R value and the theta value. R is the radius or the distance from the center of the polar system to your point. And theta is the angle made from the polar axis to a line drawn from the center to the point. So if we look at just our polar coordinate system here, this is the horizontal axis is not the x-axis anymore. It's called the polar axis. The vertical axis is not called the y-axis anymore. It's called the line y equals pi over 2. And the center, instead of being called the origin, is called the pole. So looking at an example here, it says plot the point with the following polar coordinates. 315 degrees. So the radius is 3 and our angle is 315 degrees. So starting from the polar axis, we're going to move around to 315 degrees. So it'll be on this line here. 3 is the distance between the pole and your point. So this would be 1, 2, 3. So this is the point, 315 degrees. Okay, another example. This is the point where r is -2 and theta is pi. So theta is pi, so we know it's over here. If we plotted this point, then this would be the point 2 theta, not -2 theta. So in order to graph a negative radius, what you do is you just move 180 degrees over. So we're moving back over here so that this is the point -2 pi. For this point, the radius is 2. Theta is -pi over 3. So -pi over 3, we know where that is. It's down here. And we just need to go to +2. So we're good just going out the radius on the angle -pi over 3. Then for part D, the radius is negative again, -1, and the theta is -pi over 2. So -pi over 2 would be down here. If we graph this point, then again, that is the point 1, -pi over 2. So if we want -1, we just need to go 180 degrees over here, and that is the point -1, -pi over 2. Notice if you look at this point, another way to call that point would just be pi over 2 for the angle and +1 for the radius. So just as with angles, there are several different ways you can draw or name points on the polar axis. And these are some formulas you can look at of different ways to name. You could call it with a positive radius and any 2 pi factor past theta. With a negative axis, it's any pi plus 2 pi factor after theta. So if we want to look at the point 5 pi over 4, first we'll graph that. It's right here. And it says find another representation in which r is positive, but theta is between 2 pi and 4 pi. So r is positive, so r can still be 5. But we need theta between 2 pi and 4 pi. So what we have to do is we need to go around from pi over 4 another 2 theta. And that will place it between 2 theta and 4 pi. So we're taking pi over 4 and adding 2 pi. And I meant go around 2 pi, sorry. So that would be the point 5, 9 pi over 4. So another representation for 5 pi over 4, the same point, is also 5, 9 pi over 4. Let's see. I don't have graphs. Okay. We'll have to go back. So it says, find another representation for 5 pi over 4, in which r is negative, and the angle is between 0 and pi over 2. So looking back at our same point, we want r to be negative. So it'll have to be negative 5. And how would we get negative 5? Well, remember, to get a negative, you go 180 degrees across the plane. So over here would be the point positive 5. What is that? 2 pi over 4, 3 pi over 4, 5 over 4, 5 pi over 4. Okay? So this is the angle 5 pi over 4. So if this point is positive 5 pi over 4, to get negative 5 pi over 4, we would take it back over here, which was our original point, which is what we're looking for. So another representation for 5 pi over 4 would be negative 5 pi over 4. And then part C, where r is positive, but theta is between negative 2 pi and 0. So we have r is positive, but a negative angle. So r will be positive, but to get a negative angle, then we're going to need to go all the way around this way. So that would be 2 pi minus, or let's see, pi over 4 minus 2 pi, or 5 negative 7 pi over 4. So there's 3 ways you can use a different representation for the same point. So, what if we want to go between the polar axis and the rectangular coordinate plane? We can do that using these formulas. X is r cosine of theta. And that makes sense because cosine is x over r, right? So it would make sense that we could take our radius of our polar point and the angle and put that into r cosine theta, and that would give us back x. Same thing with sine of theta is y over r. So if we take our radius and our angle and plug it in, we'd get y. We still realize that x squared plus y squared equals r squared, Pythagorean theorem. And if you're looking for the angle, it's helpful if you know y over x, then you can find the angle just by using the tangent, y over x. So not really any new formulas there, just using the ones we already know to do something different. So for example 3, it says find the rectangular coordinates of the point 3 pi. Well, we need to know what r is, or we need to know what x is and what y is. So x would be r cosine of theta. Cosine of pi is just -1, so x is -3. Y would be r sine of theta. Sine of pi is 0, so y is 0. So our point would be in the xy coordinate plane, -3, 0. We can look here, and this is just to show you how it's the same point. So the point -3 theta, or -3 pi, would be right here. And you can see that on the xy coordinate plane, I've superimposed them, laid them on top of each other here, that is also the point -3, 0. Another one here, x will be r cosine of theta. Cosine of pi over 6 is √3 over 2. So x will be -5 times the square root of 3 over 2. And y is r sine of theta. Sine of pi over 6 is 1/2. So y will be -5/2. So our point in the xy form is -5 square root of 3 over 2, -5/2. And in order to look at how to graph this point, we need to change it to a decimal. So let me grab my calculator. So this is the official answer here, your exact answer. But if we want to change it to a decimal so we can see what it would look like on our graph, it'd be approximately 4.3, or -4.3, -2.5. So let's graph the point -5 pi over 6. So pi over 6 is here. 5 pi over 6 would look like this, but remember, to make it negative, we've got to go 180 degrees around. So -5 pi over 6 would be right here. And that looks about like -4.3, -2.5. So there we go. We also need to be able to transfer back from rectangular coordinates to polar coordinates. So we can find the radius by using the Pythagorean theorem again. R squared equals x squared plus y squared. We're just solving for r by taking the square root of both sides. And we can find theta using tangent of theta equals y over x. So for example 4, if we want to find r, we need the square root of x squared plus y squared. That's the square root of 1 plus 3, or the square root of 4, which is 2. Then theta will be y over x. So tangent will be, or the theta will be the inverse tangent of negative root 3, which is negative 5 pi over 3. So if we graph this point, let's see, what is negative, or what is square root of 3? 1.73. So if we graph this, we've got the point 1, negative 1.73. So something like that for our x, using our x-axis. We found the point to be the radius r and angle negative 5 pi over 3. So let's see if that's the same. So we got 1 pi over 3, 2 pi, 3, 4, 5. Oh, I counted wrong. 1, 2, 3, 4, 5. There we go. So here's 5 pi over 3 and with a radius of 2. So same thing. Okay, we need to be able to go back and forth between equations that are rectangular and polar also. So, using the same formulas that we've already talked about, if we want to change the rectangular equation 3x minus y equals 6 into polar, we know that x is r cosine of theta and y is r sine theta. So we're going to plug those in. We'll have 3 times r cosine theta minus r sine theta equals 6. And then we just simplify. We can factor out an r to give us 3 cosine theta minus sine theta. And then solve it for r, which is what you'll usually have when you have when you're graphing a polar graph, you'd solve for r. So we'll have 6 divided by 3 cosine theta minus sine theta. So r equals 6 divided by 3 cosine theta sine theta is the same equation as 3x minus y equals 6, only in polar form. Let's change another one here. So we've got x squared plus y plus 1 squared equals 1. So that will be r cosine theta squared plus r sine theta plus 1 squared equals 1. Then we got to do a lot of algebra in here. So move that square onto both our r and our cosine. With r sine theta plus 1, we've got a full. So that'll give us r squared sine squared theta plus 2r sine theta plus 1. I'm going to take these first two terms and factor out an r, because you can probably already see, looking at our Pythagorean identities, we've got a sine squared plus a cosine squared. So that's going to be useful to us. So factor out r squared, and we're left with cosine squared theta plus sine squared theta plus 2r sine theta, and I'm going to subtract 1 from both sides to get rid of that plus 1, and we'll just end up with 0. So again, we've got sine squared plus cosine squared. That is just 1. So r squared times 1 is just r squared. Okay? We're still trying to solve this for r. So factor out an r, and we're left with r plus 2r, or 2 sine theta equals 0. So we've got two situations here. We've got where r is 0, or where r plus 2 sine theta is 0. We don't really care about this one. We just care about the one that has the trig expression in it. So I'm going to subtract 2 sine theta from both sides. And so r is negative 2 sine theta. So r equals negative 2 sine theta is the same equation as x squared plus y plus 1 squared equals 1. We'll look more in the next section on how to graph polar graphs, but we're going to look at some simple ones right now. The first one says, convert the polar equation to a regular equation in x, y, and I'm going to graph it too. So, first of all, I do want to go ahead and graph this first. R equals 4. What R equals 4 means on the polar graph is just everywhere that R is 4 is a point on the graph. So basically, this is the definition of a circle. So you've got R equals 4 here, 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 all the way around. So that means R equals 4 graphed is just the circle all the way around our graph where R equals 4. Now writing that in rectangular coordinates or rectangular equations, then we've got R is 4. We need to find X and Y. So we know R squared equals X squared plus Y squared. And we need to put it in terms of X and Y. So 4 squared is equal to X squared plus Y squared. So X squared plus Y squared is equal to 16. And that's your answer. That is R equals 4 in rectangular form. And if you'll remember when we graph circles, sure, that is the equation of a circle with radius 4. For part B, we have theta equals 3 pi over 4. To graph that, theta equals 3 pi over 4 is everywhere where theta is 3 pi over 4. Basically, the whole line of 3 pi over 4 would be graphed. How do we change that to X and Y? Use the fact that tangent of theta is Y over X. So we have tangent of 3 pi over 4 equals Y over X. Tangent of 3 pi over 4 is 1, or negative 1. So if we solve that for Y, we get the line Y equals negative X. And you can visualize that on the rectangular axis. That would be, on our graph here, that would be the line Y equals negative X. For example C, we have R equals negative 2 secant theta. Let's worry about graphing this one after we change it to rectangular form. So we know that secant is equal to 1 over cosine. So that's going to help us out here. Multiply both sides by cosine of theta, and we've got r cosine theta equals -2. How does that help us? Because we know that r cosine theta is equal to x. So we're just plugging in x for r cosine theta. So the rectangular form would be x equals -2. So if you were to imagine this graph over here to be the xy plane, then x equals -2 would be graphed like this. So now you can see that if you've got r equals -2 secant theta, if you've got something that looks like that, then you end up with a vertical line. And for part D, change this one into, oh, there it is, into rectangular form. Well, we need to focus on, somewhere we need to put x and y. So we know that if we have r squared, then we can plug in x squared plus y squared. And we know that if we have r sine of theta, we can plug in y. So what would help us here is to multiply the whole thing by r, so that we get r squared equals 10r sine theta. Now we can plug in, because r squared is x squared plus y squared. And r sine of theta is y. Okay, now we need to get that into a correct form. We got x squared plus y squared. I'm going to bring the 10y over by subtracting it from both sides. And it gives us this. We need to get this in some kind of form that's useful. X squared is fine, but having y squared minus 10y, that's not telling us what kind of picture, what kind of graph we're looking at. While if we get it in some kind of form, y minus something or y plus something, whatever, squared, then it's going to give us an idea of what kind of graph we are talking about here. So what we've got to do is complete the square for our y squared minus 10y. So we've got x squared, and then we've got our y squared minus 10y, and we're going to add something, equals 0, and we're going to have to add that something to the other side of the equation also. What do we add? Remember, it's b over 2 squared. So b is 10, or negative 10, doesn't really matter. And 10 divided by 2 is negative 5. Negative 5 squared is 25. That's what we're adding to both sides. So we get x squared plus y minus 5 quantity squared equals 25. What does that look like when you graph it? It would, let's see, let's take this to the next page. it would be a circle with the point 0.05 as its center. And a radius, r squared equals 25, so a radius of 5. So, kind of hard to picture your XY on here. Kind of tricks your eyes. But it'd be a circle that looks something like that. And that concludes this section.